Hi, everybody. This is Mrs. Marr. We're going to start a unit that deals mainly with space and depth, and specifically today I want to talk about linear perspective. There's lots of ways to show depth, including overlapping and atmospheric perspective, which we probably have already gone over before you saw this, and shading, um, choices of color, contrast. There's lots of ways. But today we're going to talk about linear perspective. And I'm going to try and help you understand the basics, but also the difference between 1, 2, and 3-point perspective. And we're only going to work from outside the cube today, but we'll also talk about inside the cube later down the road. So one thing to know up front is that linear perspective has to do with it's a method of visually reproducing 3D objects on a two-dimensional surface. Okay. And the key thing that we will talk about is, well, the horizon line and also vanishing points are synonymous with linear perspective. So we're going to start out with 1-point perspective. And if you think about the fact, I'm going to draw that a little lower. If you think about the fact that 1-point perspective, all objects have 3 dimensions. So for instance, let's say that I'm going to move this out a little bit so you can see what I'm seeing here. Okay. All objects have, let's say, a depth plus a width plus a height. Okay, it may not be that simple. It might not always be as straight as a cube, but you'll have that. And we're going to start with a cube. And we're going to start with 1-point perspective. And 1-point perspective usually has what I would say we'll call a face or a surface plane that is facing the viewer. So for instance, if I have a square down here, my height is going to be parallel with the edge of the page. My width is going to be parallel with the bottom of the page. Same for the top and the other side. They're parallel with the page. They're either straight up and down or straight across, in this case of a cube. Now, my depth is going to go back to a vanishing point. Okay, so only the depth is going to go to a vanishing point. Okay, so I'm going to make my vanishing point right over here on the horizon line. They usually, for 1 and 2-point, they're on the horizon line. The horizon line is the eye level of the viewer. So in this case, I'm looking down a little bit at this box. I can move my horizon line up and down on the page depending on whether I want to see mostly the ground, so I'm looking down onto the ground and don't see very much sky, or I can move it way down low like I'm in a city and I'm looking up at tall skyscrapers. I'd want a very low horizon line in that case. So just know that you need to have a sense of how much you're going to be looking down and how much you're going to be looking up when you decide where your horizon line will go. We can work backwards from a photograph too, and it might be clearer that way. So in this case, I want to see the top of my object, so I'm putting it below the horizon line. And my depth is going to always go back to the vanishing point, wherever that may be. Now, if I put my vanishing point to the right of my cube, I'm going to see this side of the cube. If I were to put it to the left, and I'll show you that in a minute, I'll see the other side of the cube. So in this case, everything that recedes into the distance that would be parallel in real life is going to go to the same vanishing point. So all of my sides that are parallel in real life and the side of my, let's call it the top or the roof of the cube here, are going to go to this vanishing point. They're going to appear smaller in the back than they are in the front because visually things appear smaller as they get further away. So my height, we know, is parallel with the side of the page. It's vertical. It's going to go straight up and down. My width Okay, here's my width, here's my height, and here's my depth going back to the vanishing point. These lines, my width is parallel. Even in the back, it's parallel with the front, so it's going to go straight across. Okay, only my depth is going back to the vanishing point. I had a little arrow going this way. It doesn't really matter. It's going to go to a vanishing point wherever that vanishing point might be. If I put it over here, if I have a cube over here, my height and my width are parallel with the edge of the paper, but the part that's going away from me, my depth, is going to go from the corner where we know there would be a top to the vanishing point. And then in the back, and I'm just deciding how deep I want to make this. You know, if it's a cube, it might be here. If it's a railroad car, it could be back here. Okay. If you could see into this cube, there would be another line for the floor going back here. There would be another height line that comes down from that corner, and there would be another width line that comes from here. So if this was a glass cube, you would see those corners inside. We'll talk more about that in the next video, because this would be like a room, you know, and it feels a little different if you're inside than outside. But the bottom line is these are below the horizon line, so we're seeing the top. If I were to draw my cube up here, my depth would still be going down and getting smaller as it got to the distance. Vertical still straight up and down. My width, my height still straight up and down. My width goes straight across. Now, because it's above the horizon line, I'd be looking up at it, and I would see the bottom, where here I see the top. Can you have an object that goes across the horizon line? Sure. If you were doing a building, the bottom of it would be sitting firmly on the ground, but it might extend straight up into the sky. Height is still straight up and down. Width is still straight across. But my depth, my building that is going away from me, say down a street, will go this way toward that horizon line, just like the floor did. Now, unless my building was entirely glass, I wouldn't see inside the building like that. If I have a floor that's up here, and all the windows, same rules apply. Fire escapes, the same rules apply, or shutters, or doors, or stairs. In this case, my depth is going to come down to my vanishing point. There's another one here. It's more and more subtle as you're getting, that angle is more and more subtle as you're getting closer to the vanishing point. But it's never a triangle. If I had another one down below, it would go slightly up. And if it was right on the horizon line, it would go straight across. The width and the depth would line up perfectly if they happen to be right there. Okay? So that's 1 point perspective if you're outside of the object. And this is what I mean by the face. The distance here and here, you're seeing a plane kind of squarely. It's a shape. It's not going away from you. So I would call this a face or a surface plane. Okay? That doesn't, that's not as important right now as it's going to be in a minute when I explain 2 point. So here's your 1 point perspective. If we do 2 point, okay, let's just say there's a piece of paper here. Okay. Now with 2 point, you still have a depth, and it's still going to go to a vanishing point, and your width is now also going to go to a vanishing point, and then your height is still going to go straight up and down like it always did. Okay, but that one's going to a vanishing point, and that one's going to a vanishing point. So your vanishing points tend to be towards the edges of the paper or further out. Sometimes I have people extend a piece of paper, particularly if they're going to take it home and work on it. And actually, draw their vanishing point on a horizon line that goes off the page, because that way you can always still draw to it. But for our purposes, we're not going to draw off the page. We're just going to put them at the edges of the page right now. Okay? So now I take my cube, if it's right here, and instead of having a face closest to me, I'd have a corner. And you're always going to have more dramatic lines if they're close to the vanishing point than if they're far away. So this line is going to come up here. And this line, okay, so here's my depth. Okay, here's my width. So when you're facing the corner, the building's going to get smaller as it goes this way, and it's going to get smaller if you look to the right and if you look to the left. Okay, so here's my width, and that's going back to a vanishing point. Our height is still going to go straight up and down. They should line up. These are clues. Okay, you know you have a corner. You know if you're making a cube that there's going to be a top, a line to distinguish the back of the top. We know the main rule I want you to remember is anything that goes away from you, anything that's parallel in real life, goes to the same vanishing point unless it's straight across or up and down. Okay, so we know this front of this building went to that vanishing point. So the back of the building is going to go to the same vanishing point. We know this side of the building went to that vanishing point. So this side of the building is parallel with it in real life. So it's going to go to that vanishing point. There's your cube. Now this corner is what you would draw first as opposed to a face. Okay. If we put that over here, same deal. The left side of the building is going to come back that way. Vertical is still vertical. Way over here, it doesn't matter how far away it is. The opposite side of the building is going to go to the other vanishing point. Vertical, still vertical. That gives you two clues. You know you have corners here and we need to put top on it. It's parallel. This is the back of the building. It's parallel with the front of the building in real life. So it would converge on the same vanishing point as the front of the building. This side goes back this way. So you know the back side of that roof would be parallel. It's going to come from that corner and it's going to head to that vanishing point. Okay. If it's up in the sky, same deal. Go to that vanishing point. Vertical, still vertical. We know that this back corner is going to have a face here that's parallel with these. So it's going to go to that same vanishing point. And this one from this corner, you know, and you need a back there. It's going to be parallel with the front. Front goes to this vanishing point, so does the back. Okay. If we draw this to go above the horizon line, okay, it's the same as this. The bottom of our building went to this vanishing point on this side. Vertical is still vertical. This side of the building went to that vanishing point. Height is still vertical. Okay. And just like over here, anything that goes to a vanishing point, maybe you're going to measure this off. Maybe this is going to be every ½ inch or whatever. So this side, if we go from there, it's going to go to that vanishing point. this side, parallel with the top and the bottom, they go to that vanishing point, so do these. If they're right on that line, they go straight across because they just happen to be parallel with that. Okay? So that's 2-point. 3-point, I bet you can guess. Okay? With 3-point perspective, your depth goes to a vanishing point, your width goes to a vanishing point, both on the horizon. And now your height is going to go to a vanishing point that's either way above or way below. Okay? So let's put an or there. So all 3 of these are going to go to vanishing points. So the thing to think about with this, the first 2 are always on the horizon line. Okay? Your height and your width, your depth and your width will always be on the horizon line. If you're drawing something that's way down low, say you're drawing a building and you're up in an airplane looking down at this building. Okay, so let's say you're looking down at the ground. Your depth is going that way, your width is going that way, or vice versa. The back of your building will be parallel to the front. So if the width goes this way, the back side of it's going to go that way. So here's the roof of your building, just like this one. Okay? The only difference is instead of going straight up and down now, you've got a vanishing point way down off the edge. And notice, your objects are never going all the way to your vanishing point. Your vanishing point is the end of the earth where it meets the sky. So your buildings aren't going that far back. So you'd always draw the back side of them and cut them off. And these are just guidelines. You'd erase those. Same thing down here. Your building is not going to come to a point deep down wherever that vanishing point, the farthest point you can see is. They're just guides to lead you in the right direction. So this would come down this way. This line now is also going to go to that vanishing point. And so is your height on this side. Okay? But your building's not really coming to a point, so you need to draw the bottom of your building somewhere. Just like the top went to this vanishing point. If it's way down here, it might be very exaggerated, but it's going to go up to that dot. And this side, same deal. It's going to come up to that dot. So here's your building as you're flying by it in a helicopter. Maybe it's a hospital and you're going to land on the roof, in which case even your H, these lines will go to that vanishing point, and that crossbar will go to that vanishing point. Okay, we'll talk about circles and ellipses at another point. That's too much for today. So if you're up in the air looking down at something, or maybe it's a refrigerator. I don't know. Maybe you're a fly on the ceiling looking down at the refrigerator. Okay. Even your handle, it's parallel with the side. So they're going to go to that vanishing point. Thickness of your handles will go to that vanishing point. Both of them. Okay. If you're building, say you're on the ground looking up at a building, your vanishing point will be way up in the sky. We can even use, we're going to use these same two, so I'm going to use some of these lines. But let's say, here's the corner of my building, and my width is going to go back that way. My depth is going to go this way, and my height is going to go up to this vanishing point way off the edge. So now what I'm saying is this skyscraper is so big that when I look up at the top of it, it's so far away that it appears smaller. Okay. Just like this one, we were up so high that the bottom of the building was so far away it appeared smaller, or the fridge, whichever. The top of your building, The bottom goes to that vanishing point, so does the top, even if it's going in a different direction. Okay, this one we're going up to the point, that one we're going down because we've crossed over the horizon line. Same deal, this side of the building, it's going to be very dramatic because we're so close to the point. This would come down this way, and your height is going to that. This is something they use a lot in cartoons. If you have like Spider-Man going through the city, it makes the building seem very dramatic and big. Okay, so this is when it's up at the top. This is when it's down at the bottom. Okay, and in any case, no matter how many rows or the height, technically these would get smaller up at the top because they're so far away. But I'll show you another example of that. Let's say we have a vanishing point. Well, let's say, let's come over here again. And we're going to say that we've got train tracks. That's one of the first things people tend to learn is about train tracks. What we're saying is that when it's close to the person, the viewer, it appears big. But as it gets further away to literally the vanishing point, it will vanish. So if you had train tracks, they might be this wide way down here, okay? And they might be this far apart. And as you get closer, and there is a formula for deciding how close, how fast, but we're not going there today. You get up here, they're right on top of each other, and you can't see every little detail, okay? So objects, they appear smaller in the distance. And objects appear closer together. So if we had, I don't know, happy couple walking down the side of the railroad tracks here. Okay, they're this big and they're this far apart. But if we were to draw that same couple, say that's how tall they are there, if we were to fit them, the height in here, this guy would be about that big, and they would be much closer together here than they are here. This is much shorter. Okay, if they were here, they'd be little specks. Okay, so the whole theory behind this is that things appear smaller in the distance. Even if they're the same size, they're going to appear to be smaller as they get further away and closer to the horizon. Even clouds. If you have a cloud on the distance, it might be this big. As these clouds get closer to you, they're higher. They're not as close to the horizon. They're going to appear bigger. Okay? So I think that's plenty to think about for now. I want you to play with this. Think about 1, 2, and 3 point. Get as much down as you can, just playing around with it. And we'll talk about it more in class. Have a great day. Bye now.